Xiaomi has revolutionized automotive manufacturing to such an extent that the conventional use of aluminum now seems outdated. In 2021, when the giant known for affordable cell phones and home appliances announced plans to create a vehicle capable of outperforming a Porsche at the Nürburgring and boasting superior rigidity to a Bugatti, the idea was met with disbelief. The project envisioned a chassis printed in quick sections instead of being welded. Just 3 years later, the scenario has changed drastically. The SU7 Ultra is a concrete reality that clocked 6 minutes and 46 seconds on the famous German circuit, leaving Porsche behind. The Taycan Turbo GT is lagging behind by a considerable margin. But before we begin, don't forget to like and subscribe to our channel. The most impressive aspect is not just the track performance, but the disruptive manufacturing method, Saut Dupuis. By ignoring a century of industrial conventions, Xiaomi discarded traditional processes of welding, pressing hundreds of components, and the use of gigantic furnaces. Instead, the company used artificial intelligence to develop a novel metal alloy and installed colossal machinery, equivalent to 2 sports gyms, to mold the structure. Furthermore, they integrated the battery so that it functions as the vehicle's backbone itself. The end result is a machine so far removed from current standards that its technical specifications are more reminiscent of a fictional simulator car. But every number is real. Every claim is backed up by machines that are already operating in their Beijing factory today. And, by the end of this video, you'll understand exactly how they achieved this and why the traditional automotive industry is scrambling to catch up. Let's start from the beginning. The problem with every car ever made. Here's something most people never think about. The way cars are built today is basically the same as how they were built in the 50s. You take flat sheets of steel, shape those sheets using giant presses, and then weld all those pieces together. Hundreds of pieces, thousands of welds. It's been the same process for generations. Think of it like assembling a cardboard box. You cut out all the flat parts, fold them to form the shape, and glue everything together. It works well, but each fold is a weak point. Each piece of tape is a place where something can go wrong over time. And the more pieces you have, the heavier and more complex everything becomes. In a car, each weld point is a potential point of failure over time. A standard car chassis can have hundreds of individual stamped parts joined together by hundreds or even thousands of welds. Each one adds weight. Each one vibrates slightly. Each structural component of a traditional car is also a potential point of failure, noise, and complexity. For decades, engineers have tried to reduce weight and simplify production, but the basic logic has remained the same. With the arrival of electric cars, this challenge has become even greater. An electric vehicle needs to carry a large battery pack, usually installed in the floor. This improves the center of gravity, but creates a structural problem. The battery adds a lot of weight. This weight requires a more robust chassis, which in turn further increases the car's total weight, requiring more battery power, creating a cycle that's hard to break. Tesla attempted to solve this with an innovative approach called gigacasting. Instead of assembling dozens of welded metal parts, the company began fusing large sections of the car into a single piece of aluminum. The result was fewer joints, lower weight, and more efficient production. But this method brought a critical challenge: the material's strength. When molten aluminum cools, its internal structure becomes disorganized, which reduces durability. To correct this, heat treatment is used, heating the piece in industrial furnaces to align its microscopic structure and increase its strength. The problem is that this process also deforms the part. When heated, the metal can warp or twist, even if only slightly. And in high-precision automotive components, these small deformations can compromise the fit and structural integrity. It is precisely at this point, resolving resistance without losing precision, that the new approach of companies like Xiaomi begins, attempting to overcome a limitation that until then held back the entire industry. And when you're building a car chassis, where every millimeter of precision matters, even a small deformation means the components will no longer align correctly. The doors won't close properly. The suspension points will be out of position. Everything becomes a problem. So manufacturers were stuck between two bad options: skip the heat treatment and have a part with the correct shape, but without enough strength for real-world use. Or you can use heat treatment and end up with a strong but slightly deformed part. Choose your poison. All the major automakers have tried to find a way around this. None succeeded. Some spent years researching. Most ended up accepting the compromise, adjusting their processes to the limitation, and moving forward. This became one of those problems that the industry began to treat quietly as unsolvable. Xiaomi looked at this situation and refused to accept it. Its engineers analyzed all the aluminum alloys available on the market. None of them could meet all the requirements at the same time. Strong enough, flexible enough, stable enough, and without the need for heat treatment. The perfect alloy simply did not exist. Instead of accepting the limitations of the industry, Xiaomi decided to create a completely new solution. Starting with the material itself, they developed an artificial intelligence system called Material Genome, capable of simulating millions of combinations of metal alloys in search of an ideal formula. The mission was clear: to create a metal that was strong, precise, and flexible. But that did not require heat treatment after casting, eliminating one of the biggest bottlenecks in modern automotive engineering. While a human would take thousands of years to test so many variations, the AI simulated over 10 million combinations in an extremely short time. By mixing elements such as aluminum, silicon, magnesium, and rare earths in billions of virtual scenarios, the system found a composition that met all the requirements simultaneously. The result was a proprietary alloy called Titan's metal. Unlike traditional processes, this material comes out of the mold with structural strength and dimensional precision ready for use, without the need for additional heating. This eliminates warping, reduces energy consumption, and speeds up production. In practice, this means more precise parts, better fits, and much tighter tolerances, an improvement that impacts the entire vehicle system. But creating the material was only half the revolution. To truly harness this advancement, something even more ambitious was needed. A machine capable of molding these structures on an industrial scale. And that's exactly what Xiaomi built. A new generation of manufacturing that practically redefines how a car can be produced. Gigapress operates with 9,000 tons of clamping force. When it was first unveiled to the public, automotive journalists called it the limit of engineering that humanity could achieve. It's the kind of machine that makes experienced engineers fall completely silent when they enter the room where it is. Xiaomi built a 9,100-ton version and called it hypercasting. Machine. This isn't just a bigger number on a spec sheet, hypercasting. The machine occupies an area equivalent to 2 basketball courts side by side. It weighs over 1,000 tons on its own. It heats the metal Titan to 700 degrees Celsius and injects it into a precision mold at such a high speed that air bubbles don't have time to form inside the metal as it fills the cavity. This detail about air bubbles is much more important than it seems. Air bubbles trapped inside molten metal are like invisible cracks. From the outside, the piece looks perfect. But under the forces that a high-performance car faces, these hidden voids become initial points of fracture. By using injection speeds that are too fast to allow for bubble formation, Xiaomi achieves parts with a level of internal density normally seen only in aerospace components. Every cubic millimeter is solid. See what this machine actually produces on a real production line. The rear floor section of a car is one of the most structurally important parts of the entire vehicle. In a standard car, this section is composed of 72 separately stamped steel pieces, all joined by 840 individual weld points. Each of these pieces needs to be manufactured separately, transported, stored in inventory, removed, aligned, secured, and welded one by one. The entire process takes several hours and requires many workers and machines. Hypercasting Xiaomi's machine produces this same section as a single piece in just 100 seconds. 72 parts become one piece. 840 welds become 0 welds. Working hours become 100 seconds. Furthermore, the single-piece cast section is 17% lighter than the traditional multi-part steel version and generates 2 decibels less road noise because there are no small gaps or imperfect welds vibrating against each other at highway speeds. And after the machine produces each piece, the work doesn't stop there. Each casting is analyzed by X-ray images and high-precision laser sensors right there on the machine, even before it leaves the press. If the AI that controls the quality system detects any flaw of any kind, the piece is automatically rejected before a human even sees it. The quality standard is essentially superhuman because no person could inspect with that level of detail and at that speed. A new chassis section comes out of this machine every 90 seconds. Now, if you think that's the most impressive part of this whole story, what Xiaomi did with the battery will truly surprise you. The big turning point came when Xiaomi stopped treating the battery as dead weight and started seeing it as a structural part of the car. Instead of just being a heavy box to store energy, it began to function as the very skeleton of the vehicle. Cell-to-body technology. The battery cells are no longer isolated in a separate compartment, but integrated directly into the chassis. The top of the assembly becomes the cabin floor itself, and the cells actively contribute to the car's structural rigidity. But the cleverest detail lies in the orientation of these cells. Normally, battery safety valves face upwards, requiring extra layers of protection between the battery and the passengers. Xiaomi simply reversed everything. By pointing these valves downwards, towards the road, it eliminated the need for additional internal protection. The result was a direct gain in structural efficiency, less material, less weight, and an extremely thin assembly, approximately 120 mm thick. This lowers the center of gravity and dramatically improves the car's stability. And the structural impact is even more impressive. The Xiaomi SU7 Ultra achieves approximately 51,000 nm of torsional rigidity, a number that easily surpasses extremely robust vehicles like the Ford F-150 Raptor, which is in the range of 25,000 nm. In practice, this shows a paradigm shift. The battery has ceased to be an engineering problem and has become the solution. It's also more rigid than a Bugatti. Chiron, a car made by a technology company using the battery as its backbone, is more rigid than one of the most expensive street cars ever produced. And this rigidity isn't just an impressive number. It's what makes all the other systems in the car work better. When the chassis simply doesn't flex under any load, the suspension is able to work perfectly at all times. The shock absorbers respond exactly as they were calibrated. The tires remain in full contact with the asphalt, even in aggressive cornering. The car behaves exactly as the engineers designed it, because the base never moves. And the engineers designed it to handle 1,548 horsepower coming from 3 electric motors. Each motor spins at 27,200 RPM, a world record for a production electric motor. To give you an idea of how fast this is, Most electric motors in high-performance cars reach around 20,500 RPM. Xiaomi's motors spin 35% faster, generating more power from a smaller and lighter assembly. This is on the level of jet turbines. Without the Titan metal chassis, without the CTB battery structure, this level of power and rotational speed would create forces that would destroy a conventional automotive structure over time. But because the material, the manufacturing process, the chassis design, and the battery integration were developed together as a single connected system, each element perfectly supports the other. What this really changes. Xiaomi proved something with the SU7 Ultra that goes beyond an impressive car. They proved that starting completely from scratch, without assuming things need to be done the way they always have been, can be the most powerful engineering strategy available. Using AI to design a new alloy, instead of just tweaking existing ones, redefines the starting point. Building a casting machine larger than any existing one, and using it to replace dozens of parts with just one, redefines the manufacturing process. Inverting battery cells so that they become a structural part of the car redefines what a car truly is at a fundamental level. Xiaomi Vision GT concept, with its theoretical 1900 horsepower and aerodynamics that would be banned in Formula One, is not science fiction. It's a preview of what Xiaomi can already build now with the technology that already exists today in its factory in Beijing. Hypercasting machines are producing chassis sections every 90 seconds. The CTB architecture is already in the hands of customers. The impact of this advancement transcends the success of a single brand, serving as a global wake-up call for the entire automotive industry. The traditional manufacturing model, which relies on joining hundreds of steel components through countless welds and treats the battery as an accessory item, is being replaced by an innovative concept. In this new vision, raw materials, machinery, structural design, and energy storage are conceived in an integrated way from the initial draft, using artificial intelligence to achieve solutions that surpass conventional human perception. This represents a complete redefinition of the essence of an automobile and its production process, something that is under close observation by all major manufacturers worldwide. For those who appreciate topics related to technology and major industrial challenges, engaging with this content is essential to keep up with the upcoming transformations in engineering, which are expected to occur at an accelerated pace. The question remains whether other giants in the technology sector, such as Apple, Samsung, or Google, can replicate this trajectory and develop, from scratch, a vehicle capable of competing for the top spot in the global market. Do you think another tech company, like Apple, Samsung, or Google, could do exactly what Xiaomi just did and build a car from scratch that truly competes at the highest level? Leave your answer and let's talk about that.